In the previous module, we described a way to account for batch effects when we know what the batch effects are. But we also saw evidence for us not really knowing exactly what the batch effects are. What are the sources of variability that are affecting our data? So a more general model would be this surrogate variable model, and where we have, just like before, the outcome of interest, which in the example that we've been looking at is sex, female or male. We have measurement error, but now we have this new term that describes the correlation that we see between samples. To simplify this part of the model, we are assuming that it is determined by a series of columns that are considered the batches. So if we only had one batch, one of the columns of W could just be a series of zeros and ones, where 1 means you're in one batch, 0 means in the other. But now, we don't really know who's a 0 and who's a 1, and we have to actually estimate that. So the approach here is difficult because we don't know what W is, we don't know what alpha is, we don't know what beta is. All these things have to be estimated. These seems almost impossible to do, but there is a trick that statisticians have been using for decades called factor analysis. So notice that if beta is 0, if the effect of the outcome of interest is 0, then all we're left with is the sources of variability. We have the measurement error, and then we have the effects that are associated with batch, the surrogate values that we are calling batch effects. So now the exercise is to find W and alpha. And by making certain assumptions about how these are uncorrelated and how they're uncorrelated to noise, we can actually estimate these W's and these alphas. And we're going to explain how to do that in the next module, where we explain singular value decomposition and principal component analysis.